Okay, welcome back. Okay, so what we're doing in this question is, or in this video, sorry, is looking at question 12 from the SACE Specialist Maths Exam from 2019. And with this question, it was involved taking some derivatives, doing some integrals of a curve that's given parametrically in the xy plane. Okay, so if we get down to the question, this is what we've got. We're looking at the parametric equations describing the motion of a particle that's moving in a spiral pattern towards the origin. Okay, we're given the formulas here for the x and y coordinate as a function of t, and we're told that t is time in seconds and x and y are distances measured in centimeters. And the first thing to do is we want to sketch this curve from those parametric equations. So you can put that into a calculator to come up with a sketch. As we don't have a graphics calculator handy, what we're going to do is just look at a few points and just see what's going on. And so one point to look at would be t equals 0, and at t equals 0 we're going to have x equals 0 because sine 0 is 0, and y is going to be equal to cos of 0, which is 1, times e to the minus 0 over 5, and so that's just e to the 0. Okay, and that's just 1. And at pi over 2, this next point to look at, we're going to have x equals e to the minus pi over 10, and we're going to have y equal 0. Cos of pi over 2 is 0. And then at t equals pi, we're going to have x back equal to 0 again, and now y is going to be equal to minus e to the minus pi over 5. And it's going to keep going like that. So you're going to have the radius sort of decreasing the whole time exponentially, and the curve is going around in a clockwise direction around the origin with this ever decreasing radius. Okay, so now that we know what basically what it's looking like, what we can do is just plot these points at a distance of pi over 4, and so we're going to have a point around here, and then the next point is going to be around here somewhere. The next point will be around down on the lower half of the y-axis at about minus 0.5 or so. Then we've got a point on the negative x-axis, a point on the positive y-axis up at around 0.3, and another one on the positive x-axis, and then finally at t equals pi, it's going to be on the negative y-axis at somewhere under minus 0.2. Okay, and so what we end up with is this logarithmically decreasing spiral pattern, which looks something like that. Okay, so that's a rough sketch of what's going on. And now what we want to do is show that the velocity vector of the particle is given by the expression here. Okay, so if we think about a vector x, which is our position vector, sometimes you'll see r used as a position vector. We'll just use x, the vector x here, and that's equal to xt y of t. Then that's going to be equal to e to the minus t over 5 sine t, and e to the minus t over 5 cos t. Okay, that's just, haven't done anything here except taken the definition from the previous part of the question and put it into a vector. And now the velocity is going to be the derivative of the x vector taken with respect to t. And you can see what we need to do here is use the product rule, because you've got two functions of t multiplied together. So if we differentiate the first exponential, we're going to get minus 1 over 5 e to the minus t over 5 times sine t, and then we're going to differentiate the sine t, which will give us a cos t, so we get e to the minus t over 5 cos t, and then the y component, same sort of thing is happening, differentiate the exponential, except now when we differentiate the cos, we're going to get a minus, so it's going to be minus e to the minus t over 5 sine t. Okay, and if we take out some common factors, let's take out the minus 1 over 5 e to the minus t over 5, and what we're left with is sine t minus 5 cos t. And for the y component, we're going to have cos t plus 5 sine t. Okay, and that's basically what we needed to show. Okay, so that's that part taken care of. Now, for parts C and D, what we want to do is find the velocity vector of the particle at the time t equals pi over 2. Okay, so we're going to have to substitute in a particular time, which is t equals pi over 2. And using our expression from the previous part, that's going to be minus 1 over 5 e to the minus pi on 10. And because t equals pi over 2, so we've got sine is 1 and cos is 0, and so x component is going to be 1 and the y component is going to be 5. And we can work that out to 3 significant digits, and we're going to get minus 0.146 and minus 0.730. And we also want to find the speed of the particle. Okay, so the speed is going to be the magnitude of the velocity. Okay, so in this case, we're going to have a 1 on 5 e to the minus t over 5. And we want the magnitude of this vector here. So it's going to be the magnitude of a vector with components 1 and 5. So it's going to be the square root of 1 squared plus 5 squared. I should probably change this t. I can change that to, I'll change the whole fraction to pi over 10, because we've substituted in t equals pi over 2 already for that vector anyway. Okay, and so what we're going to be left with is the square root of 26 over 5 e to the minus pi over 10, and that's approximately equal to 0.745. Okay, so that's all we need to do for that part. Now, part E, this has got a few bits to it. First part is write an expression for the term in terms of t for finding the length of the path that the particle has taken for t going from 0 to pi. Okay, and so here what we need to do is take an integral. And so the length of a curve is going to be given by the integral from 0 to pi, and it's going to be the speed, okay, because it's basically the magnitude of v dot v, and that's what the magnitude of v is, and that's what the same as what the speed is. Okay, so the speed that we worked out before, and so that's going to be integral from 0 to pi, and then it's 1 over 5 e to the minus t over 5. We need to make this a function of t because we're integrating over t. And then with the vector component, we're going to have sine t minus 5 cos t squared plus cos t plus 5 sine t squared dt. So that's an expression in terms of t for finding the length of the path. So this is enough to answer that question, part 1. Now in part 2 we're actually going to have to do something with it. We're going to show that it can be simplified to the square root of 26 over 5, and then the integral from 0 to pi of e to the minus 1 over 5 t dt. Okay, and so the key part of this is looking at what happens with that square root. And so that square root was sine t plus, let me just go, sorry, it should be a minus 5 cos t squared plus cos t minus plus 5 sine t squared. And so if we expand that, we're going to get sine squared t minus 10 sine t cos t plus 25 cos squared t. And then the second part, we're going to get cos squared t plus 10 sine t cos t plus 25 sine squared t. And the critical thing that's happening here is that this term is cancelling with that term. Okay, we've got plus and a minus. And if we group everything else together, what we're going to get is 26 of sine squared t plus cos squared t, and that's equal to the square root of 26. Okay, sine squared t plus cos squared t is equal to 1. So the length is going to be the integral from 0 to pi of 1 over 5 e to the minus t over 5 square root 26 dt. And we can take the 1 on 5 and the square root 26 out the front because they're just constants. And so that's what we needed to show in the question. Okay, and now the last part is we want to use this to actually calculate a quantity to three significant figures. Okay, so the length is going to be equal to the square root of 26 over 5. Then it's going to be, we need to integrate e to the minus t over 5, so we're going to get a minus 5 coming out as a constant, e to the minus t over 5, and we're integrating that from 0 to pi. And because there's a minus sign, we can swap the limits around, and so we're going to do the 0 limit first and get rid of the minus sign. So the 0 limit, when we put t equals 0, this becomes, hang on, let me just take the 5 out as well, because that's a little bit simpler. So what we can do is take out the 5, and that's going to cancel with the 5 on the denominator. So let me just get rid of that. Well, let's just write this again. Okay. So the 5 on the denominator cancelling with the 5 inside, and so we just have to worry about the exponential. When we put t equals 0, we get 1, and when we put t equals pi, we get e to the minus pi over 5. Okay, and to 3 significant digits, that's going to be equal to approximately 2.38. Okay, and that's it. So if you like this video, don't forget to click the like button. And if you want to see when more videos are posted, then you can subscribe to the channel and get notifications and that sort of thing. Otherwise, if you've got any questions or comments, then please leave a comment below. Okay, and till next time, thanks for watching.